All right, welcome back. Today you are comparing transformations. So we've learned about 4 different types of transformations. So go ahead, that's your warm-up to label them. Yesterday's warm-up was what are 3 other types, or 2 days ago maybe. So the 4th type is what we just learned. Okay. The 3 types of transformation that preserve length and shape are translations, reflections, and rotations, right? We just moved the shape around. We didn't change the size of it, okay? And these are called isometries, okay? So that's just kind of a special name for these 3, and that just means equal length. So it keeps the length the same of the different shapes that we moved around, okay? Remember, translations just moved us up and down, right, left and right. Reflections are like our mirror image, right? And rotations, we're turning it about some point. Okay, so that's all it says, up, down, left, right, mirror image, and turn about a point, okay? And isometries, just a good word to know and understand what they mean if you see the word isometries, okay? So dilation is our 4th transformation, and remember, dilation does not preserve length since it makes an object bigger or smaller, right? So dilation will not always preserve length, which is a problem, okay? In some cases, not always others. So dilations is not in one of these categories, okay? So it's different than the isometries. Okay. All right, so we have this example here, okay, and they graphed 3 triangles for me. I have triangle A, B, and C. And the first question is just, what is the transformation that maps A to B, okay? Now notice what I'm looking at here, A is a different size than B, right? So I know it can't be a translation, reflection, or a rotation, okay? Now I'm guessing it's a dilation, okay? But I should make sure. So I want to make sure that when I draw the line through all these points here, that they all meet at the same point. Remember, this is how we tell if it's a dilation or not. And we'll go through this guy like this, these points. Okay. I might need to make this line a little longer. It looks like it's going to go through the origin more than likely here. Okay, let's extend this line a little bit here. And if I extend this guy right here, one more time, it is in fact going to go through the origin. So I can say that this is a dilation about the origin. Okay. And if it asks me the scale factor, remember that's new over old, and since they mapped A onto B, it's going to be A over B. So I just do a length 1, 2, 3 of A over 1, 2, 3, 4, 5, 6 of B, and 6 over 3. Oops, you guys can't see that. Sorry. 6 over 3 just equals 2. So this is my scale factor. Okay. So if you find a dilation, remember you can find out where the center of dilation is and the scale factor, okay? Now the transformation from A to C, okay? Now I notice that this is 2 by 3, this is 2 by 3, so I'm not changing the size, so it's probably some sort of translation, reflection, rotation. Now a reflection over this doesn't make sense, right? Because it turns, right? And a translation doesn't make sense because I'm not just moving it up and over. So it's got to be some sort of rotation. And remember, rotation is you connect the 2 points that match here. Okay, let me do this in a different color. Let's see if I have one. So I'll do this in dark blue here, okay, with a Sharpie. I would connect these 2, and then I would need a protractor to measure the angle between the 2, right? And this looks like about a 90-degree angle. I don't have a protractor on me, but if I do a 90-degree angle here like this, it's about 90 degrees, okay? So the transformation of this is a 90-degree rotation, and that's going to be counterclockwise about the origin, okay? All right. So remember, if you have a rotation, you need to tell me which way I'm moving. So because I'm moving from A to C like this, it is a counterclockwise motion. If it had moved this way, it would have been a clockwise motion, okay? And my center point there is the origin, in fact, okay? So that's kind of how we can tell a difference between different types of transformations, okay? I'm going to give you another one similar to this, okay? So they give me 4 triangles. Okay, we're starting with the one ABC and mapping it here, here, and here, okay? And again, just tell me what kind of transformation. So they said from triangle ABC to PQR. So I'm going from 1 to 2 here, okay? So how did I go from here to here? Now notice the size is the same, so it can't be a dilation. I didn't flip it over any lines, right? Okay, so it's not a reflection. I'm not turning it in any way, shape, or form. So it's some sort of translation. And if I think about this from C to R, I'm going up 2 over 1, 2, 3, 4, right? So I'm going up to the right 4. So this is a translation, okay? Now, a transformation can be more than one object, or more than one transformation. So some of them will work in multiple ways, okay? So you just kind of got to learn the difference between them. Now, the next one is translation from triangle ABC to LMN. So I'm going from 1 to 2 here. Okay. Now this one, if I look at it, if I were to put a mirror up in between these two, again, if I flipped it over, it would be perfect, right? So this is a reflection, okay, about, or I guess over the x-axis, okay? Because again, if I just place my mirror here, I knew it wasn't a dilation because it didn't get bigger or smaller, okay? Translation would move it down, so this would be the flat line here, okay? And it would be going up like this, so that doesn't work. And it's not some sort of rotation because I'm not turning. Well, actually, it could kind of be a rotation, right? If I did it about this point, it could be a 180-degree turn in some way, shape, or form because I'm turning it completely sideways, okay? So what is the transformation from ABC to XYZ? So I'm going from 1 to 2 here, okay? Now this one, I'm definitely turning in some way, right? Because I'm not making it bigger or smaller. I don't know if you guys can see this. You might need some more light here. Not making it bigger or smaller, okay? But again, I can do my rotation lines, right? Draw a line from one point, then to the other point that's going to be in the same spot, okay? And again, that's probably some 90-degree turn counterclockwise, okay? 90-degree rotation counterclockwise about the origin, okay? So it's moved directions around the origin. Okay. So your homework, it's getting complicated today. You have question number 1, do all the parts. 2, I just want you to do parts A and B. 3, do all the parts. 4, just do B and C. 5, do all the parts, okay? Have a great day. Have an awesome time with your sub. We're going to kind of go over more transformations tomorrow, so be prepared for that. We'll talk to you later. Bye.